That's a ratchet way of tripod.
Yeah,
Get
somebody
over
said that.
You want me to hold it?
No, I need
If he
a.
leaves the books like good enough, he can do it.
That looks nice. There you
Yeah. That's that student view. That's a POV.
I know where you got that from.
POV.
All right, so one other thing about the equation or parabola is so the quadratic functions. So I can go through the point. So let's name any type of point. Which point would you like to name?
4, 3.
2 what? Oh no, we're gonna pick a different point. So any point. Vertex. Sorry, which one do you say?
-2, 8.
2.
And 8.
8. Okay, that's fine. 2 and 8. Okay, so I have a vertex 2 and 8, and I'm gonna give you a random point. Can you tell me any other random point that you would like?
49. 16, 24.
Damn.
Wait, what?
Oh God, don't do it, please.
So
He's a pretty good one.
I don't know about you, but I like 420.
Yeah. Join the life, man.
Okay, so
No, very powerful.
I don't know what I meant, but
We don't know what that means.
You could switch it for 6 and 9.
yeah, that's
Better.
worse. Okay, so Michael, I know you're in love with him, but. Okay, so 4 and 8, and so I have a random point between 2 and 8 and 4 and 20, and the vertex is 2, 8. Okay, so I want you to find the equation of this parabola that go into those 2 points. So any ideas? We have 3 different format of parabola, of quadratic functions. So we would like to ask you which one is the best fit, and we will ask you says how we're gonna find the equation going through those 2 points.
By graphic.
Well, you can graph, but it's not gonna be very, very accurate. But okay, any other way like algebraically?
Doing that.
Distance?
Vertex form.
Correspondence?
I actually thought this was but I guess you do the
Standard form now.
Okay, so I'll give you an idea.
Vertex form.
So my vertex is 2, 8, right?
Yeah.
And so I'm gonna label this. I'm gonna label this as called a vertex. Okay. So you guys see that vertex over there? Okay, and this one's roughly at 2, 8. And there's one other point that's gonna be what?
420.
420. Okay, so 420.
Young flame.
I like how the board looks better through the.
Okay, so 420 here.
You can see the
So
board.
it's an equation that's going through those 2 points.
Can you do point
So-
slope form?
Point slope form is not for a problem,
Oh.
but there's an equation that's gonna go through both points. Okay, vertex form. So how would I do this question in terms of vertex form? So if I have a vertex, it should be y. It should be y is equal to what? A.
X minus h squared.
Okay, so are we okay here?
Yeah.
So we can plug in 420 or 28? 28. Okay, so let's plug in that. 28. Okay. So now I'm going to show you. Now this is not done yet because we don't know the value of a. Okay. So I'm going to plug in an equation like this: a parenthesis x minus 2 parenthesis plus 8, and then we're going to say squared. Okay, and then we're going to say add a slider for a. So we know the parabola is probably facing up, but we don't know what the A value. The A value is a range of different values, so we're gonna show you here. We're gonna show you the range of different value here. So we're actually gonna play the slider a little bit, and we're gonna let it run, and we're gonna see when the one point that's almost touching each other. See that point is touching each other?
Whoa. What?
Right here, right? Roughly right here, but it's not really because if I zoom in, it's not really touching each other. So the A value could change. There's infinite among the chance that the A value can be, but there's only one chance of the A that's gonna go through that green points right here. So if I were really fast, I can like, okay, so like this, like almost like this, about 3 something, but we don't know what is it because we go in and not really touching. So maybe at 4, so we can change it to 4, but it doesn't really work either.
It's 3.
Okay, it's
It's
3,
three
so let's
solid,
change
yeah.
3. 3, is that gonna go through there?
Exactly, yeah.
Okay, but how do we know it's 3 if we just have no decimals?
We can do the math.
You can do the math. So how do you do math?
The X.
You plug in 3 for A.
minus B.
So I hear, right? So we got 420. So that's our favorite number here. So y is equal to A times x minus 2 squared and then plus 8. And we say, okay, that we have one other point, 420. We never use those points. But what's a 420? 4 and 20, that means this is the x value, this is the y value, right?
Also, just plug it in.
Then we can plug in here, yes. We can plug in the x value, so it's equal to A times 4 minus 2 squared plus 8 is equal to 20. And then I can go ahead to figure out 20 is equal to A times 2 squared plus 8. Am I going too fast?
No.
I'm going to subtract A on both sides. So I'm going to get 12 equal to A times 4. And then A is equal to 12 divided by 4, which is roughly 3. So A is equal to 3. I solved algebraically. Now I can plug it back in here to figure out the equation is equal to 3 times x minus 2 squared plus 8. So you know that answer is that. With 2 points, you can find the equation.
So you use vertex form?
I will use a vertex form if a vertex is given, right? Now there are other things maybe given in different ways, so we're gonna test you that. So the first question, I'm gonna go through this. The first question is, I'll assign this question. I says, hey, first question, I have a point, I have a vertex. So if I have vertex given, I will definitely use vertex form because that's the best thing. So what would you like to name your vertex at?
6, 9.
6 and 9.
So let's do like a 7-11, how about that?
Sorry for a second.
Yeah.
And then the point should be racetrack.
The point's gonna be where?
Wawa.
Racetrack.
No, here, let's put 3 and 7.
Oh, how about 11 and 7?
3 and 7, okay, let's do that. Okay, so by looking at this, do you know if the parabola is facing up or down?
Down.
Yeah, it's down.
Down.
Probably down, right? So can you find the equation of this one?
Sure.
Hold on, let me change this to -7, I think that's better.
That means it's a bad 7-11.
Okay, now the second choice, the second question I'm gonna ask you is actually ask you a little bit harder, is I'm gonna give you 3 specific points, but there's none of the point at vertex, okay? So this is a point, the first point is point A. I'm gonna use a -3 and 0. And the point B is gonna be, let's say it's 5 and 0. And the point C is gonna be, point C is gonna be, let's say it's 2, 11 maybe. Okay, so I want you to find both. The first one is a little bit easier because we already go through the example. But the second one is also something implying something though. Second one, those points are there for a reason. And special two of those points, it should be able to tell those points as specific points.
And
Oh, I know.
A and B are like the, will be the opposite.
Okay, so will be the what?
Okay, so let's do
What do you call it? Corresponding?
Oh, they can be corresponding to each other, good. But also I hear they are located. The standard form doesn't really help you too much.
Wouldn't you do it the same way you did it?
Okay, the first one you can definitely use the same way as I did it, but the second one's different. The second one has no vertex giving. None of those points are vertex.
what is that one?
Standard form can probably do something, but it's not very helpful because you could actually have to use system of three variable three equations. And that,
Okay, let's see.
and that's actually,
Is that negative? Yeah.
but at least get the first one first. So if you get the first one, we'll work on the second one. The second one's a little bit harder. I don't know, I'll wait until everybody, you can check with the other person who finished it.
Wait, you got negative? Oh, yeah, yeah.
You're looking for A. Oh, yeah, I forgot about A. You look at A again. So that- four. Get negative 140.
Wait, did I do the first
Let's see
one?
your thing.
Side.
Yeah.
What's your first person?
Oh, yeah. So then this guy's first.
Is it okay that I got a fraction?
You can get a
16,
fraction.
16. It's supposed to be a fraction. This guy likes fractions.
I do like fractions.
Oh, no, in the beginning of the year you said that you hated fractions.
No, I says you just have to learn how to work with fractions.
Okay, so I got negative 2 over negative 5, which gives me positive 2 over
Let me answer now, at least.
I feel like I just negative 2.
There we got a square, not doublets.
What you got?
I don't know, that's the first one.
I didn't put the squares there.
Sure.
Oh, negative 1 over 4.
Hey.
Negative one what?
Over 4.
Negative 1 over 4, that's what you, Beth, got?
So I got 2?
I forgot the
Yeah.
squared sign. So I have to square the.
Lenny, did you work it out? Now the second one, trying to think about what other form you can use. Definitely don't use standard form because standard form is going to give you a system three variable three equation. Because why?
Oh, wait. So you have the y itself, so it's easy.
So in this case, right? Lenny, you finished? Waiting for you. So what is my vertex form? Y is equal to what? X minus what? Negative 7, right?
Oh, wow. That's actually kind of hard.
So y equal to x minus negative 7 because that's negative, but the a value is in the front and there's a square and then it's plus 11. So that's equal to a times x plus 7 squared plus 11. Everybody get to this part. And then we're gonna plug in the negative 3 and 7. So we're gonna plug in this for y and let's plug in for x because that's gonna dictate how wide the open is because that a is gonna tell me are they reflection, they opening down or opening up. So this point is gonna dictate that. So it'll be 7 is equal to what? A times
Negative 3 plus 7.
negative 3 plus 7 squared plus 11. So I'm gonna subtract 11 on both sides first. That's gonna give you negative 4. is equal to a times 4 squared. Then I'm gonna divide by 4 squared on both sides, so it'll be negative 4 over 4 squared, that's equal to negative 1 over 4. So that is my equation, y equal to negative 1 over 4 times x plus 7 squared plus 11. So that was my answer here. Okay, yes, it is also 0.25, but fraction is good. Fraction right here is gonna tell me they are opening down, and later on we're gonna talk about what's a negative 1 over 4 do. Now I hear, right, you should know those 2 points. Those 2 points called what? What do they call?
X-intercept.
X-intercept. So if you look at the thing that says factoring form, the factoring form says there's 2 x-intercepts, right? So the way to tell is this, x, that's another way to think about it, is this one's negative 3 and this one's 5. So that is gonna be y. What is the factor form? A times x minus p, x minus q. So p and q are the x-intercepts. So what can I plug in?
Y equals a x minus negative 3.
Minus negative 3, thank you.
Can you just put like plus 3 there?
You can. And then x minus 5. And then that's gonna be y is equal to what? A times x plus 3, x minus 5, right? Now, how do I find an a value in here? Which point I haven't used? Okay, so this one is x, this one's y, right? So can you go ahead and finish that part? So then I will do y
Wouldn't it be 11
Yeah.
is 11, thank you, so it'll be 11 here.
equal to
A times what?
2 plus 2.
2 plus 3 is 5. And then 2 minus 5,
Negative 3.
negative 3?
negative 3. So A is equal to 11 over negative 15. So that's my equation, says y is equal to 11 over negative 15 times x plus 3 and then x minus 5. And that's it.
Easy.
And then you can find the equation that go in through all those 3 points. If a vertex is not given, see if the 2 x-intercepts are given.
So you only use that equation if there's x-intercepts?
Yes, because x-intercept is going to give me factor form. Question about quadratic. Okay, so right now we're going to teach you something a little bit more, kind of the heavier. It's going to our algebra 2, but it's going to our pre-calculus part. This part is more extensive. And we're going to talk about why are they extensive.
Oh, wait.
Okay, so you guys know today we give you a vertex and we give you a point, you can find an equation. Or I can give you 2 x-intercept, you can give me a point, right? Nick, I just went over the whole section, you're gonna have to watch the video.
So I do every night.
Okay. So I can give you x-intercept, and I can give you a. You can find me the equation. Here's how I do it. If I give you x-intercept, it's x equal to 2, and x equal to 7. And I'll give you an a is equal to 2. Can I find the equation?
Yeah.
Well, here's an easy way to look at it. Why is that x minus p and minus q? I can move the 2 to the other side, can I?
Yeah.
So in this case, if I move the 2 to the other side, that's going to become minus. That's how y is minus p and minus q. Am I going too fast? Well, here x equal to 7, so it's x minus 7 is equal to 0. So that becomes the factor. If each zero can give me a factor, it just move back. So then I can say, oh yeah, that's equal to f of x is equal to 2 times x minus 2, x minus 7. Okay. What if my x-intercept is at somewhere else? X equal to 2 over 3, and x equal to maybe negative 1/2, and we say a is equal to 3. No, don't plug in. Make sure this is in a factor form. This is x equal to 2 over 3, means 2 over 3, 0 is your x-intercept. X equal to negative 1/2, that also means that's x-intercept. But can I set it equal to 0?
Yeah.
How do I do that?
Subtract.
Multiply both sides by what?
2 over 3.
You can do that, but or you can multiply both sides by 3. So it'd be 3x equal to 2, right? And this one's gonna be 2x equal to negative 1, right?
Oh, and I just subtract 2.
And just subtract 2, so it'll be 3x minus 2
Equals 0.
equal to 0, and then this one's a 2x plus 1 is equal to 0. Guess what? This is a factor. So it'll be it'll be 3 times 3x minus 2 times 2x plus 1. So that becomes the equation of the problem. If I give in those information to you. Now, the next question is a little bit harder. The next question is ask you, I know most of you guys in this room not gonna get it the first time, but just bear with me all the way through, and I will teach you the theory behind it. But, so first day we're gonna come to this, it's gonna be kind of hard. So what if I told you one x-intercept is this?
Oh, God.
Okay.
Now you're going a little far.
Okay, and then we're gonna also tell you the a value is equal, I'm gonna give you 1. So can you find me the equation of this problem? So this is the first x-intercept, so 1 minus square root 2.
Don't you square both sides?
No, don't square both sides.
Wait.
But this implying something though. This x equal to 1 minus square root 2 implying there is another x-intercept. Because you have one x-intercept, usually in a problem, you're gonna have another one. What do you think another one is gonna look like?
Plus or minus?
Good, what is it?
I don't know.
What do you think that is? That implying what? That implying
1 plus or minus.
x equal to what?
1 plus or minus.
Plus square root 2. That implying those two. One's a plus and one is minus. That's why the plus minus keep on coming back in place. So those two is a what? They call it what? Conjugate, right?
So we're back to this now?
Yeah, we're going back to this. And we're actually going to prove this is true. We're actually going to prove this is true. Now, we're going to show you like this. So we're going to use the same thing as what we're doing here. We're going to say, okay, x is equal to 1 minus square root 2. And we're going to say x equal to 1 plus square root 2. So we're going to change it to the factor. How do I change it to factor? I move everything to the left side.
So would you subtract 1?
I will subtract 1 first, so it'll be x minus 1 is equal to negative square root 2. And then x minus 1 is equal to what? Square root 2.
Yeah.
And I'll move the square root 2 to the other side too. X minus 1 plus square root 2, and x minus 1 minus square root 2, right?
Okay.
And I can write an equation just like how I write it here. I can say the a is 1, x minus 1 plus square root 2, x minus 1 minus square root 2. How many of you guys are lost?
Yeah.
Okay, so I basically, this is a 1 x-intercept. That implies there's another x-intercept on the other side.
Okay, that
Because
makes
usually plus minus, right? But I'm moving everything to the left side. So I'm subtract 1 on both sides, adding square root 2 on both sides. That becomes this long equation. This becomes a factor. This becomes a factor, just like what I did here. When this one is here, I move everything to the other side. It changed to a factor. If a 0 is going to give you a factor is going to give you a 0. Now we get to this form. You say, okay, can I simplify this? You can. But here is what we learned in the past that we're gonna put in back in play. Michael and Lang. Here's what we're gonna do. We're gonna use a parenthesis here. And this parenthesis is gonna help. Okay. Why is that parenthesis help? Because what happened is you look at this. This one's like look like an A. If we just say A is equal to x minus 1, and we say B is equal to square root 2. What does that look like? A plus B, right? And A minus B, right? Does that make sense? This is equal to A, this is equal to B, this is equal to A, this is equal to B. But if those two are foil to each other, what am I gonna get? Difference of a square, right?
Why?
Okay, so.
Difference of square is always coming back to play. In SAT, it's always coming back to play. Now we're gonna show you a shortcut. How do I FOIL this? It's gonna be 1 times x minus 1 squared minus square root 2 squared.
Okay.
We just basically a plus b and a minus b is equal to a squared minus b squared. A squared minus b squared.
But if you square a square root, doesn't it like come?
Cancel out. Good. You're on a good. So now this is equal to 1 times x minus 1 squared minus 2. Now can I FOIL this?
No, you have to. You can't kill a baby.
You can kill a baby, but it's gonna FOIL this, so we get x squared minus 2x plus 1 and then minus 2, right? That's equal to what? X squared minus 2x minus 1. I give you one beautiful equation like that. X squared minus 2x
And then don't you do that?
minus 1. So now with this one, it's gonna give you 2x-intercept. We're gonna show you why there's 2. We already know that there's 2, but we're gonna show you how that is 2. Okay? How do I find a 0? How do I find the x-intercept of this equation? So we got this new equation. We can say, okay, this is f of x equal to x squared minus 2x minus 1. But how do I find the x-intercept?
Make y 0.
Make y equal to 0, good. 0 equal to x squared minus 2x minus 1, right?
Mm-hmm.
Are we okay here?
Yeah.
Now, can I factor this?
Yeah, you could do the. You can't do the box method.
It doesn't work.
Square.
Would you parentheses the first two?
You can do that, but let's think about what's the old-fashioned way.
Wait, what's the x?
Oh,
X equals negative.
x and then parentheses.
No. What's the most old-fashioned way to solve quadratic formulas?
Factor out.
Using quadratic formula.
Oh.
Okay, so A is equal to what?
X.
1, not x.
Oh,
B is equal to what?
2x.
Negative 2.
Oh, so
C is equal to what?
Negative 1.
Okay, we're gonna prove that there's 2 x-intercept here. We're gonna show you. So now we're gonna have this, right?
Wait, where'd you get 1? The regular, the x.
Yeah.
This is a number in front of the x
Oh,
squared.
would it be x equals?
So now x equal to negative b,
Yeah,
which is
that's
negative
right.
negative 2, plus minus, what is it?
4, no.
Negative 2 squared, right? Minus 4 times 1 times negative 1. All over 2 times 1. Am I going too fast? This is quadratic formula.
Yeah, I remember this
Now, what's negative times negative?
Positive.
Positive, so that's gonna be 4 plus minus 4, right? Plus 4 all over 2. Wait. Is equal to 4 plus minus square root of 8 all over 2. You guys remember this? Can I simplify square root of 8?
No.
Oh, yes.
No. Maybe.
Square root of 8 can be simplified into what? Well, 8, right? Square root of 8 is equal to 2 times 4, and then 2 times 2, right? You can take out a 2. So it'll be 4 plus minus 2 square root of 2 all over 2. Oh no, this is 2, I'm sorry, this is 2. I don't know why they changed it to 4. So this is a 2, this is 2. Am I going too fast?
No.
Now I'm splitting. So it'll be 2 over 2 plus minus 2 square root 2 over 2. That's equal to 1 plus minus square root of 2. X-intercept. See, they always come in pairs. Okay? They always come in pairs. That's why I told you, when they have 1 minus square root 2, they have a 1 root is 1 plus square root 2. It's always come in pair, they conjugate. So the way I think about it, if you have radical, right, they always come in pairs. If you have something square root something, 1 plus square root 3, then you got another one's 1 minus square root 3. Not only that, with I also work too. So those of you guys have imaginary girlfriends. You'd rather have 2 imaginary girlfriends than 1 imaginary girlfriend, right?
Oh, wow.
Right, Si?
Why actually me? Oh, wow.
So you'd rather have 2, but the same thing, if you have radical friend, you have bad friend, you're not gonna have just 1 bad friend, you're gonna have 2. You know, like I will give you a bad influence. So like Nick and Chris.
Oh, wow.
Right?
Michael?
No, Michael and Nick. Maybe. Okay, so Chris is gonna have 2 bad friends. Make sure you have radical, right? If you have radical something, especially in quadratic term, in quadratic they always come in pairs. It's 1 plus square root 5 and 1 minus square root 5. 1 plus square root 2, 1 minus square root 2. So they are pairs. So like the 1 plus square root 2, it must have 1 minus square root 2. That's the roots. Now if you have 1 plus square root 5, 1 minus square root 5. Even square root 2, you're gonna have minus square root 2. They just come in pairs. They come in pairs. You gotta understand that they come in pairs. Not only that, imaginary can be true too. 1 minus 2i, what do you think the other friend is going to be?
1 plus 2i?
1 plus 2i. There's 2 imaginary girlfriends that you have. Sorry.
One can only dream. One can only dream.
One can only dream, right? If you got dream, must dream too. Okay, so that's why they come in. Now this one, I'm not going to test you, but in the future, we're going to come back to this topic a little bit. So I know this is kind of difficult for you to understand. This is A plus B, A minus B. Now that's not the first time you see it. I'll give you some practice question, but you don't understand, I'm not going to put on the test. But just this part is a little bit more challenging. Tomorrow we're going to go to a discriminant and the projectile function.
Okay, here we go.
Wait, what is it?
All like this part. Like this part, to be able to give you a 0, you solve for the equation. That one I'm not going to put on this test. I'll put on the next test.
Next text? Okay. It's like in 3 weeks, right?
He's just being sorry. He's just being sorry.
That's my ratchet tripod. You guys see work?
Perfect.